Hi everyone, in this video we'll go through 3 marker problems from part C. Here are different problem types from matrices. You have to prove that this particular left hand side expression is same as right hand side expression. Similarly here, AB the whole transpose is equal to B transpose into A transpose. And here, A into adjoint of A should be equal to adjoint of A into A. So these kind of things. And then very important concept, Kramer's rule. Here is a step-by-step solution to each of the problems. Whatever is there in the bracket, that needs to be simplified first, right? So B plus C. First we will have to calculate B plus C. Whatever matrix we get by adding B and C, that should be multiplied with matrix A. And then here on the right hand side, multiply matrices A and B, then A and C, and then add them. So matrix obtained from this left hand side calculation and right hand side calculation should be same. So you say RHS is this particular matrix, LHS is this particular matrix, both are same, hence they are equal. Similarly, second problem, multiply matrices A and B, right? And then take a transpose of it, right? This means you'll have to take transpose of it, that is interchange the rows and columns. Then similarly on the right hand side, right? First take the transpose of matrix B, interchange the rows and columns of matrix B, then interchange the rows and columns of matrix A, and multiply these two matrices. Then you'll observe that the matrix on the left hand side is same as the matrix on the right hand side. Thereby, this particular expression is true. So here's the third problem. In this problem, you'll have to find the adjoint of A, right? For adjoint of A, you have to swap the elements of this particular diagonal and change the signs of this diagonal. So minus 1, 4 will become 4 minus 1. And here in this diagonal, 2, 3, signs will reverse. So it's plus 2 here, it will become minus 2. Plus 3 will become minus 3. So this is how you find adjoint of 2 by 2 matrix. So here in this expression, you take matrix A, multiply with adjoint of A. So matrix A is the first matrix. In second expression, adjoint of A is the first matrix. And then you have to prove that it is equal to determinant of A into identity matrix, right? So you'll have to take a 2 by 2 identity matrix, which is this one, right? Diagonal elements are 1 and other elements are zeros. And then you have to multiply with the determinant. You have to prove that all these expressions give the same matrix. There's a technique when you multiply the matrices, right? Generally, it's prone to mistakes. So what you can do is you can refer a video on matrix multiplication technique in my playlist. So what you have to do is you have to take the first row elements, minus 1, 2, write it as minus 1, 2 here. Then take the column elements, 4 and minus 3, put here 4 minus 3. Again, here also you repeat minus 1 and 2. Then take second column elements, minus 2 and minus 1. Do this for the first row. Second row, what you do is just take 3, 4 here. That is second row elements. 3, 4, 3, 4. Write it. 3, 4, 3, 4. You write it. And then what you do, you copy whatever is there in the first row. You have 4 and minus 3, copy it. 4 and minus 3. Then you have minus 2 and minus 2, copy it. Minus 1 and minus 1, you copy it. And then you can put the signs later, right? Plus, 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 you can put all the signs. Let me go through this once again. So take the first row elements, which is minus 1 and 2, right? Now you write minus 1, 2 here. Now you copy that same minus 1, 2 here, 2 times, right? Now take the first column, 4 and minus 3, write 4 minus 3, right? Then second column, minus 2, minus 1, just write it like this. Then at the end, you come and put the plus sign in between. Now what you do for the second row, you take the second row elements, 3, 4, 3, 4, write it 2 times. Then you just copy whatever is there in the first row. 4 and minus 3, just copy it here. Minus 2 and minus 2, minus 1 and minus 1, just copy it. Then put plus signs in between. That makes it easier and avoids mistakes. This is an important concept, Kramer's rule. Here again, in Kramer's rule, you take the coefficients of x, y and constants. 7 and 6. These numbers are constants, 7 and 6. So you take the coefficients 3, 7, 3, 7, 4 and minus 1, right? Then in the second matrix, what you do is, instead of 3, 7, you put 7 and 6. In the third matrix, here, instead of 4 and minus 1, you put 7 and 6. So now you notice, in the first matrix, you'll have the coefficients of x and y. 3, 7, 4 minus 1, 3, 7, 4 minus 1. In the second matrix, instead of the x column, you'll put constant 7, 6, 7, 6. In the third matrix, instead of the y column, you will put constant 7 and 6. Then you find the determinant of each of these matrices. So x would be determinant of x by x, that is determinant of the second matrix by first matrix becomes x, and y is nothing but third matrix by the first matrix, right? This one by this one becomes y. So you can verify the answer. You can take this original expression, whatever values of x and y you've got, put it in this particular expression. It should give you the right hand side values. 3x plus 4y is 7. So when I substitute x and y, I should get 7. There is an entire playlist on matrices and determinants. You can go through that playlist for more details. Here's the list of questions in determinants. See, one thing about determinants is you can get any kind of determinant related questions, any question, right? There is no particular pattern and every problem is different. So it's better to understand the concept, right, as to how we simplify determinants. Now, there is a detailed video on determinants. I think close to 10 to 15 problems of determinants have been solved in one video. I think it's part 3, right? It's part 3 of matrices chapter, right? Part 3, I guess. Just refer that video. You will see all the determinant problems, and also technique in each of the problem is explained. The technique is explained. And also there is a video on determinant properties, right? The proofs. There are different determinant properties. Proofs of each is explained in another video. You can go through the proof there. Now let's look at these problems here. Let's go through this problem step by step. In the first problem, when I simplify and find the determinant of the left hand side determinant should be same as the right hand side expression. So I will take the left hand side. This one is LHS, right? This entire thing is LHS. Now what should be the first thought process? First is you have 1 and 1 and 1 here. You have to somehow make it 0. Objective in calculating determinant is you have to make it 0 as much as you can, right? So I'll make this one as 0. How do I make this as 0? Simply by subtracting this with this. When I subtract this row element with this row element, it becomes 0. So what is the operation? Subtraction. So it is row 2 minus row 1. Similarly, in the last row also I can do the same thing. I subtract this with this, row 3 minus row 1. So it will become zeros. Now I can't just subtract these two elements. I have to subtract the entire row. So subtract the entire row. This one with this one, this one with this one, then this one with this one, this one with this one. Like that you subtract, right? You get this particular expression. Now note, this is important formula here. This is an important formula. C square minus A square can be written as C plus A into C minus A, right? A square minus B square can be written as A plus B into A minus B. This is very important. You have to remember this while solving determinant problems. So you can expand it like this, then take the common factor. So second technique is always the objective should be to take common factor out, right? You should do certain operations in a way that you will get some common factors. Now you take the common factor here. C minus A is common and A minus B is common. So what I'm left with this simplified determinant. Now it is simpler, right? So once it becomes relatively simpler, then you can calculate the determinant, right? How do you calculate the determinant? You take the first row, leave the first column, and then cross multiply, right? Then you ignore the second column and first row and cross multiply like this. Then you ignore the third column and first row and cross multiply. So this way you find the determinant, and then you will see that whatever expression you've got is same as RHS. Now next problem, right? Now this is solve. Solve means what? You have to find the value of x. Anytime in any question you see solve, it means that you have to find the value of the variables like x and y. Here you have x, so you have to find the value of x. Now there is a pattern here. You see every number in every element is similar. You have 2 plus x here, you have 3 plus x, here 4 plus x. Here it's 2, 2, 3, 3, 4, 4. So there is some kind of similarity or commonality. What you can do is, you can try to add all these columns. Just think, when I try to add all these columns, I'll get a common element. 2 plus x plus 3 minus 4, I'll get 1 plus x. 2 plus 3 plus x minus 4, I'll get 1 plus x. Again, 2 plus 3 plus x minus 4, I'll get 1 plus x. So I have common element. Once I get common element, I will take the common factor out. I'll get like this, right? So, like I said, two techniques. First, try to take the numbers and make it zeros, right? And second, try to take the common factor out. So now I see 1 and 1. What should strike immediately? Since there is 1 and 1, let me subtract. Because if I subtract this with this, it will become 0. If I subtract this with this, it will become 0, right? If I subtract this with this, it will become 0. This with this, it will become 0. So what is my operation? Operation is row 2 minus row 1, row 2 minus row 1, then row 3 minus row 1. So I'll subtract like this. The entire row I have to subtract, not just these elements. Right? Now you notice you have lot many zeros and you have a simplified determinant. Now you can calculate determinant. Right? This way. That's why I'm telling you, refer the determinant video. It's very helpful. Close to 15-20 problems I explained on how each of the operation you can choose. How do you decide which operation to do? All that is explained in that video. Now here's the third problem. Right? Here again there is a similar pattern, right? All similar pattern. Just add all the columns. When you have similar pattern, add all the columns. Right? Now when I add, you get common factor. Take this as common. Then you get simple. You have 1 and 1. Again, what do you do? Subtract row 2 with row 1, row 3 with row 1. Like this. That's all. Now you'll get zeros. Now it is fairly simple. Now you can calculate the determinant. This problem. Here what you will do. First technique. See if you can find the common things out. Right? And second thing is subtract in such a way that you can bring zeros out. Right? You can make it into zeros. Now you see A is common here. A is common here. Here you see B is common. Here C is common. Now take ABC as common here. Right? So you get this kind of a matrix. Now again I can take A as common. Second time. Again I'll take A as common, B as common, C as common. So what will happen? This second time. See? First time I took. Again second time I'll take. Now I'll get everything as ones. So now I can calculate determinant. Simple, right? So if you know how we should approach a problem, what should be the thought process, then it will be easy to solve determinant problems, right? So for this, you'll have to go through as many as problems, solve as many as problems you can, so that this thought process becomes quick and clear. So I'll not be able to explain all the techniques in this video. You'll have to refer the other video in Matrices and Determinants playlist. Now here is another problem, right? Again, you have this kind of a determinant. There is 1 and 1. What should strike you immediately? Subtract. Subtract this with this. Subtract this with this. That's all. You'll get 0, 0. You'll get 2 zeros here, right? You'll get like this. Here, you see B minus A minus B. C minus A minus C. That means you can take common factor out. I can take A minus B as common factor. And here I can take A minus C as common, right? If I take common, since it is B minus A here, and I've taken A minus B as common, I should put minus 1. Similarly here, right? Because it's reversed. The signs are reversed. So I'll get minus 1 here. Right? Now I find the determinant directly. Now parabola is the simplest chapter and easy scoring chapter. Right? Be it in 2 marker or 3 marker, parabola is the easiest one. Right? So there is again a revision video on parabola. There is also detailed video on parabola. There is a playlist. Go through this. The main idea of parabola, if you can figure out what kind of parabola it is it upward parabola, downward parabola, left-handed parabola, right-handed parabola, if you know how to identify the type of parabola, then solving all these sums is just very simple, right? First step in parabola is finding out what kind of parabola it is, right? So I'll not be able to explain how to find out all the parabola types in this video. You'll have to go through the playlist on parabola and the revision video, both, right? You can go through detailed video and revision video for you to understand how you identify what kind of parabola it is given the problem, right? Now here's the list of problems. There are step-by-step solutions here. I'll go through them quickly. The first one is find the focus equation of directrix and length of lattice rectum of this particular equation. So here they've given you the equation. From the equation, you'll have to figure out what kind of parabola it is. That should be the first step. Now, you'll have to remember the 4 formulas, right? You have 4 formulas for each of the parabolas, right? For downward parabola, there's one equation. For upward, there's one equation. For left-handed, one. For right-handed, one. So you have to by heart these particular 4 equations. Now, since the equation is given, now you shift this plus 16y to the other side. It will become minus 16y. Now, you'll have to remember which parabola it is. It is downward parabola. This one is downward parabola. Why it is downward? Because there is negative sign here. It's negative sign. That means here you observe y is negative, right? It is 16y, minus 16y. So y is negative. Where is y-axis negative? On the bottom side of y-axis. Now this is y-axis. This is x-axis. On the bottom side is where you see negative values, right? This is where you will see all negative values, -1, -2, -3. Now, you see it's minus y. Therefore, it's a downward parabola. This is the clue to tell you that this is downward parabola. Now, what is the focus for downward parabola? Focus will be on the negative side, on y-axis, because there is y here in the equation. So it's negative on the y-axis. So this is the focus. So this is focus. What is focus? Focus on y-axis. So it will be 0 and a. This is the focus. So focus is 0 and a. 0 and a. And instead of a, what do we have? From this formula, you can find out what is a. This is equivalent to minus 16y is equivalent to minus 4ay. This is the equation, right? Equation is x square is equal to minus 4ay for downward parabola. Now, this means that minus 4a is equal to minus 16. Minus 4a is equal to minus 16. Therefore, a is equal to 4. Now, a is equal to 4. But focus should be negative of a, right? It should be, focus should be 0 and negative a. This is the focus because it's downward parabola. So 0, what is a? A is 4, minus 4. So this is the focus. Now, equation of directrix. What is directrix? It's exactly opposite of focus. So if this is the focus and this is the directrix, right? This is directrix, exactly opposite side. So if this is minus a plus a, this is directrix, right? On which axis? Y, right? So y is equal to plus a. This is the equation for directrix. Then length of latus rectum, this is fixed. Doesn't matter which kind of parabola it is. Length of latus rectum is always 4 into a. So 16. Now this problem, here point is given. This is the point. They are saying the parabola passes through point -1, -3. Now you have to first plot where is -1, -3 in the axis. -1, this is y-axis, this is x-axis. This is negative side of x-axis, minus, right? -1, -2. This is all negative side. And this is negative side of y-axis. So here both the coordinates are negative. So the point is somewhere here. Point is somewhere here. Now the parabola passes through this point. Now which means it is downward parabola or it can be left-handed parabola, one of them. It can be either left-handed parabola or it can be downward parabola, because even in left-handed parabola, that is, if you have a parabola like this, even on the left-handed parabola, it can pass through this point here and in the downward. So it could be any of these parabolas. Now how do we know exactly which is the parabola? You'll have to look at the axis. They've given axis y-axis. What does it mean when you say axis is y-axis? That means focus is on y-axis. What does it mean? Focus is here. This is where the focus is, because it's on the y-axis. Now it can't be upwards because the point is negative. So it has to be below, negative side of y-axis. If focus is here, that means it's downward parabola, right? And what is the equation for downward parabola? It is x square minus 4ay. This is the equation. Now, I don't know what value of a is, right? So what I will do, the point is given -1, -3. I take the same equation. I'll substitute x value and y value from this point, -1 and -3. I'm substituting it here. Now once I substitute, I'll get a value, which is 1 by 12. Now I'll take the same equation, x square is equal to minus 4ay. I'll take this equation and I'll substitute a value. A value is 1 by 12. So I'll substitute a value. Then I'll put minus 4 and y, right? So it will be x square is equal to minus 1 by 3y. Now I can shift 3 this side. So it will be 3x square and shift y also. So I'll get 3x square plus y is equal to 0. Now I have to find equation of directrix. What will be equation of directrix? Exactly opposite of this point is directrix. This is directrix, right? So what will it be? It's y-axis, that we know. Y is equal to a, right? Y is equal to a. Why? Because here a is positive on this side of the axis, right? So it will be y is equal to a. A is 1 by 12. So y is equal to 1 by 12. Now third problem, here focus is given, directrix is given. Find the equation of parabola, right? And equation of tangent. Equation of tangent at the vertex. This is the vertex. This origin is the vertex, right? 0, 0. Now focus is 4, 0. Now this should remind you, this is a comma 0. And which parabola do you have? A comma 0 in right-handed parabola. Why? If you notice, this 4 is x-axis. So you have focus on the x-axis, that is, and it's positive. So this is positive side of x-axis. So focus is here. Now if focus is here, that means it's right-handed parabola. Very simple, right? Now once I know right-handed parabola, what is the equation? Y square is equal to 4ax. This is the equation. You know a value, which is 4. Substitute, you'll get the equation. Now equation of tangent. Tangent is perpendicular line to the vertex, right? Which is the This is the vertex. What is the tangent? The perpendicular line to it is this one, y-axis. This is the perpendicular to this particular vertex. Now, what does this mean? Y values are there in this entire line. What is x value? X is 0, right? Anywhere in this point, x is 0 only, right? So, therefore, equation of tangent is x is 0. Fourth problem, here again focus is given, directrix is given, right? Only thing you'll have to find which parabola it is. Here it is 0, minus 3. That means y-axis is negative, right? That means similar here, right? Negative means here. The focus is here, 0, minus 3. So it's downward parabola. Now you know downward parabola equation is x square is equal to minus 4ay. A is given 3 and y. Substitute, you'll get the equation of parabola. Remember one thing, focus is 0 minus a. Focus is 0 minus a. That is 0 minus 3. So what is value of a? A is equal to 3. Remember, don't write a as minus 3. We are prone to these mistakes normally. A is 3. A is 3. A is 3. Don't put a as minus 3. A is 3. Right? So now here, when you are substituting, you have to put a as 3, not minus 3. Fifth problem. This passes through a point and it is symmetric with respect to y-axis. Now what is the clue? One is the point. Point x and y both are positive. That means somewhere here in the first quadrant. So that means the point is in the first quadrant. This is the first quadrant, right? You have positive y and positive x. So the point is here. That is one clue. Now second clue is symmetric with respect to y-axis. Symmetric means the parabola is equally divided on the y-axis, right? Now this is y-axis. It's equally divided. Where? Y-axis. Therefore, the parabola has to be like this, right? So it's a upward parabola. What is the equation for upward parabola? It is x square is equal to 4ay, right? Now using the point, you will substitute the coordinates here. You will get a. Once you get a, take the same equation and put the value of a, and you will get the equation of parabola. The last problem, you have to find focus, equation of directrix, and coordinates of ends of lattice rectum. Equation is given, x square is equal to 8y. Now x square is equal to 8y, so this is nothing but upward parabola, right? X square is equal to 8y, it's equivalent to x square is equal to 4ay. This is the equation for upward parabola, right? So from this you'll find the value of a. Now once you know the value of a, what is the focus? This is the focal point. For upward parabola, this is the focal point, right? So it is 0, comma a, because x value is 0 here and y value is a. So 0, comma a. What is a? 2. So 0, comma 2. So focus is 0, comma 2. Directrix. Directrix is exactly opposite side of focus. So if this is focus and this is directrix, so it's going to be minus a. So it will be on which axis it is? Directrix is on y axis. So y is equal to minus a. So y is equal to minus 2. Now coordinates of LR. Coordinates of LR are these 2 points. These 2 ends of the parabola. 2 ends of the parabola gives you the coordinates. Now here it's proven that this distance is 2a and this distance is a. Now this becomes the coordinates. So this side x-axis is negative, so minus 2a. This side x-axis is positive, so plus 2a. Y is same, y is positive, right? Plus a and plus a. So simple, substitute the value of a and you'll get the coordinates. 4, 2, minus 4, 2. Bill discounting. So in the earlier video where 2 marker questions were covered, bill discounting was explained. That video has both 2 marker and 3 marker problems. You can refer the same video for bill discounting. Permutations and combinations. This is a big chapter and questions can come from anywhere in the chapter, right? So it's important to understand the concept. We can't go problem by problem trying to solve the problems. You have to understand the concept, right? However, here are a few of the problems that you could practice, right? Find the number of permutations of letters of word committee. Engineering, any word can come, right? These are just examples. You have unique, you have rainbow, right? Now you have to find the permutations of different varieties of questions here. Then you have, these are combinations related problems. Combinations, right? How do you form a team? How do you select people? How do you form a committee? How do you form a cricket team? So all these are combination related problems. Let's go through these problems. So go through the revision video for permutations and combinations. It will explain the basic concepts of this entire chapter. Now here, first problem, find the number of permutations of letters of word committee. How many of these have all the vowels together? Committee, how many characters are there? 4, 8, 9 characters are there. So first you have to find total number of permutations. In every question, first find the total number of permutations. It is number of characters, number of letters are 9, so 9 factorial, by repeated letters. So you have M twice, you have E twice and T twice. Then you should find the number of permutations for having all the vowels together. What are the vowels here in committee? You have O, I and E. You have E twice, so O, I, E, E. You consider this entire thing as one unit because they have to be together, right? This entire list of vowels should be together, so it's one unit. Now within this list, within this vowels, they can be arranged in different way, right? It can be O, I, E, E, or it can be E, I, O, E, or it can be O, I, E, E, something like this. Any kind of arrangement is possible. So you have to find the number of arrangements in this unit. So number of arrangements is number of letters. 4 letters, so 4 factorial. In the denominator, you should have number of repeated letters. You have only E repeating twice, so 2 factorial. Now, we have done with vowels, right? Now we'll have to find remaining letters also. Remaining letters are there, no, in committee. They can also be arranged in different ways. How many remaining letters we have? 4 are gone out. You have 9. 5 letters are there. 5 letters and then this 1 unit. You can swap it anywhere, right? 5 letters and 1 unit. You can place it anyway, right? For example, if I take C, M, M, T, T, and I can have this oval like this. Then I can have O, I, E, E oval here, and I can have C, M, M, T, T, right? Then I have C, M, then I can have this oval here, and M, T, T, something like this. So all these combinations is possible with letter and this particular unit, right? So you have to include this as 1 unit, ovals as 1 unit, 5 letters, so total units is 6 units. So arrangements is 6 units, 6 factorial by repeated letters. How many repeated letters are there? Do not include the vowels because vowels we have already included here, repeated letters. In the remaining letters, what are the repeated letters? M. M is repeated twice. T is repeated twice. So 2 factorial into 2 factorial. Now, last step, never forget that. Last step, you have to find total arrangements. Total arrangements is always multiplication of this one and this one. So this one, like this. You have to apply multiplication here. This one, begin with T, end with T. So when you have begin with T and end with T, the word is starting with T and ending with T. Remaining all letters come here. So there's only one way you can arrange this. You cannot move these letters anywhere. There's only one way. It is fixed position. This is a fixed position. This is one way. Now you go to remaining letters. 2 are gone out of 9. So you have 7 letters. So arrangements is 7 factorial by repeated letters. Right? Now total arrangements, you have to take this one way, this one into this one. This is your total arrangements. Now words ending with MITE. So again, this is fixed. You can't change the place. It has to be in the last position, in the end. So one way. And remaining letters as 5 letters. So 5 factorial. See, there is a difference. Here we added remaining letters and the unit. But in these cases, we did not add. So whenever you have a fixed position, you need not add a unit there. See, you'll be wondering as to why you have not added 1 unit here, right? I could have added this 1 unit. Or here I could have added 1 unit. Correct? This MITE I could have added here. No, the difference is I cannot do that because it's fixed position. I cannot move this letter here, nor can I move MITE. They are told it has to be then the last position. So whenever the position is fixed, you don't add that unit. That's the clue. Last one, in how many ways no 2 vowels are together? The vowel should not be together. What does it mean? I should not have these vowels together. I can't have IE together or OE together or EO together. So basically, I should have the other letters in between the vowels. The other letters C, M, M, T, T, T. I should have the other letters in between these letters. So you'll have to use permutations concept. So how many vowels are there? 4 vowels. These 4 vowels should be sitting in between the other letters. Here you can have vowels. Right? Here you can have vowels. So how many places are there? It has 6 places. 1, 2, 3, 4, 5, 6 places. And 4 vowels need to be fitted in. So 6P4. 4 vowels to be selected and placed in 6 positions. So 6P4 and repeated letters. Let's not forget repeated letters in the denominator. E is repeated twice, so 2 factorial. Then you come with the remaining letters. Remaining letters is 5, right? 5 5 letters. So arrangements is 5 factorial by repeated letters M and T. 2 M's and 2 T's. The total number of arrangements is multiply this 1 and 2. So this is the total number of arrangements. Now similarly you can solve these problems also. Engineering. Have all E's together. So you consider all E's as one unit. So one way of arranging. Then remaining letters is 8 letters plus this 1 unit. So 9 units. So arrangements is 9 factorial by repeated letters. Begin with green. Now begin with green means this position is fixed. Once the position is fixed, I don't add an unit. Right? Here I will not add. See here, when I say remaining letters, I don't add this unit green. I don't add here. But here I added. Here I added. Because they have not told in which position it should be. It can be anywhere. The E's can be together anywhere. It can be first place, second place, third place, fourth place. It can be anywhere. That's why I add 1 unit here. Third one is begin with T and end with T. Here also, position is fixed. Right? So one way you can arrange. Remaining letters would be 9 factorial by this much. You don't have to add this unit because it's fixed position. Then fourth one is have all 3 E's together. Now they said all E's together, but they have not told where. It can be anywhere. So here you will add unit. Remaining letters and 1 unit. 9 units. So arrangements is 9 factorial by repeated letters. So here's the total arrangements. You have to multiply the unit arrangements and the remaining letter arrangements, and that will give you total arrangements. No 2 ovals together. Same concept. No 2 ovals together means there has to be other letters in between, consonants in between like this. So you'll have to use permutation formula. So we have 5 ovals. And how many positions? Simple, right? There are 6 other letters. So 1 position extra, 7. So 7, P, 5. And repeated letters. Then remaining letters is 6 letters. Find the number of arrangements and multiply this one with this one, 1 and 2. Similarly, you can solve for Mississippi. Only different problem here is 4 S's are not together. 4 S's are not together. So you know what to do when 4 S's are together. For not together, you take total arrangements minus 4 S's together. Total arrangements, you got it from here, right? This is total permutations. Take this one and subtract it from 4 S's together. That will be not together. Now unique. How many of them end with Q? So this is again fixed position, right? There is no unit concept. Then begin with U and end with E. Again fixed position, no unit concept. How many of them begin with consonant? Okay, let's go through this. How many of them begin? What are the consonants here? Consonants are, you have 2 consonants, N and Q. Remaining everything else is ovals. Right? In unique, you have only N and Q as consonants. Remaining letters are vowels. 2 consonants. It should begin with consonant. That is, the starting letter is N and the other letters, or it can be Q and other letters. So how many ways I can, put the letters in the first position? How many ways? 2 ways. Either I can put N or I can put Q. So 2 ways. Right? So this is 2 ways. Then I'll figure out the arrangements for remaining letters. This is 6 letters. 2 letters are consonants. 4 vowels. So remaining letters is 4. 4 letters. Then 4 letters by repeated letters. U is repeated 2 times. What is total arrangements? See here again I have not taken the unit concept. Why? Because fixed position. In the first place, N and Q is there. Right? So you multiply this consonant arrangements and remaining letter arrangements. Here it's 2 ways. Remember, it's not 1 way, 2 ways, because 2 letters are there, N and Q. 2 ways. So 2 into this one. So this is the answer. This is also similar to the other problems. You can solve this. Here's the way it is solved. You can look at it. Now here combination related problems. A man has 10 relatives. 4 of them are ladies. 3 gentlemen. 3 children. You need to invite 7 relatives. And the condition is 2 gentlemen and at least 3 ladies. At least 3 ladies means it can be more than 3. Right? Exactly means equal to 2. So now first I write this. First I write gentlemen, ladies and children, and total. Total means what is the requirement? It should be 2 gentlemen and at least 3 ladies. So it should be 3 ladies, greater than 3 ladies. Right? So now I'll write down 3 gentlemen are there, 4 ladies are there, 3 children. Right? You can write different combinations. So I need to get 2 gentlemen. So I put 2 gentlemen, exactly 2 gentlemen. Ladies should be greater than 3. Now we'll come up with the different combinations. You should have exactly 2 gentlemen and you can have more than 3 ladies. So what are the different combinations? It can be 3 ladies or 4 ladies. Maximum ladies is here 4. So 3 ladies and 4 ladies. Now you want total number of invitees to be 7. So you have 2 gentlemen, 3 ladies. How many people are left now? 5. So you need 2 more. So you'll take it from children, 2 children. Now similarly, you'll go to second combination. Exactly 2 gentlemen. So leave it like that. Ladies can be 4 here. Now in this case, you take 4 ladies. So total is 6. 2 plus 4 is 6. You need 7 invitees. So you'll take 1 child. Now what you'll do, you'll write the combinations. 3 C2. From 3 gentlemen, 2 men needs to be selected. So 3 C2. From 4 ladies, 3 need to be selected. 4 C3. From 3 children, 2 needs to be selected. So 3 C2. Right? You'll calculate. Then in the second combination, 3 gentlemen, 2 needs to be selected. So 3 C2. 4 ladies, 4 needs to be selected. So 4 C4. 3 children, 1 needs to be selected. So 3 C1. Right? Now you add up these totals. Right? 36 plus 9, you add up. So you get 45. So 45 ways are there. Now second one is exactly 3 children. Exactly 3 children, at least 1 lady, at least 2 gentlemen. Exactly 3 children. Right? So now this becomes a constraint. Exactly 3 children means all the combinations should have 3 children. And at least 1 lady, at least 2 gentlemen. At least 1 lady means greater than 1. At least 2 gentlemen means greater than 2. Now let's look at the combinations. Total should be 7. So 3 children. So let me fix 3 children. Once I have selected 3, how many people I need to form 7? I need 4 people. Now this 4 people amongst gentlemen and ladies. So I'll take 1 lady. So minimum is 1. It can be greater than 1, right? 1 or more ladies. So I'll start with minimum, which is least number, 1 lady. Now 3 and 4. 4 people are selected. I need 3 more. So I'll take it from men, 3 men. Now second combination, I can increase the ladies. I can take 2 ladies, right? If I take 2 ladies, 3 and 2 becomes 5. I'm left with 2 more invitees. So I'll take it from 2 gentlemen, right? Now can I proceed further? If I proceed further, I will not get a valid combination. Say, if I take 3 children, and then if I take 3 ladies, there are 4 ladies, so I can take 3 ladies. If I take 3 ladies, how many gentlemen I should take? 1. But this is invalid. Why? Minimum, at least there should be 2 men. Here, 1 is not valid in that case. So this combination is not valid. So now I find the combinations. 3 gentlemen, 3 to be chosen, 3 C3. 4 ladies, 1 to be chosen, 4 C1. 3 children, 3 to be chosen, 3 C3. Similarly, the second combination, add up both the values, you'll get 22 ways. Next problem, from a class of 9 boys and 7 girls, 12 students are to be chosen. So 9 boys, right? 7 girls, 12 to be chosen. At least you should have 6 boys. At least 6 means greater than 6. At least 4 means greater than 4. In how many ways can this be done if particular boy is always chosen? So one boy is always chosen. That means you've already chosen a boy. Now you have to choose the remaining students. Since you've chosen a boy from 9 boys, so the remaining boys is 8. Right? Since you've chosen already 1. And how many you have to select now? You need at least 6 boys. But 1 you have chosen. So how many boys you have to select? 5. Right? So now these are the numbers. Girls anyway it will remain the same. And students, 12 students need to be formed. 1 you have already chosen. 1 boy is already chosen. So how many are left? 11 students. So you have to choose 11 students. So now we will form the combinations. Girl should be greater than 4. So I can start with 4, right? Greater than 4, let me start with a small number. 4. If I choose 4 girls, I should have 11 students, right? I should choose 11 students. So that means 7 should be boys. Simple. I can have 7 because it should be greater than 5 for me. I can choose 7. Next combination is I can choose 5 girls. If I choose 5 girls, then I should choose 6 boys. Then I can choose 6 girls. If I choose 6 girls, then boys should be 5. So I have 3 combinations. You can try some other combinations, but it will become invalid. I can take, say, 7 girls. If I take 7 girls, then I should take 4 boys. But I should have minimum, 6 boys. But 1 boy is already chosen. So I have to choose 5 boys. I can't have 4 boys. Right? So this is invalid. This is invalid. Now you find the combinations and get the answer. You add all these. Here, a team of 11 is to be chosen from 18 cricketers. 6 are bowlers, 3 are wicket keepers. Now, how do you form the team in such a way? There are at least 4 bowlers and 2 wicket keepers. At least 4 bowlers means it should be greater than 4. And at least 2 wicket keepers means greater than 2. Right? Now, 11 is to be chosen. 11 should be chosen finally out of 18. So you start with the, say greater than 2, start with 2. Greater than 2, start with 2, right? Then with 2, you see different combinations. Then start with 3, you see different combinations this way. So when you have 2 wicket keepers, you should have totally 11 chosen, right? You have others also, right? Other than bowlers and wicket keepers, you have others also. So if you have 6 bowlers and 3 wicket keepers, that means 9 are covered. Out of 18, 9 are covered. That means others there are 9. There are 9 other cricketers who are not bowlers and who are not wicket keepers. So you have to come up with these combinations. If I take 2 wicket keepers, I can choose 4 bowlers, 5 others, and 5 bowlers, 4 others, like this. So take this number as fixed, right? To make it easy. First start with 2 wicket keepers, then change this combination. Then start with 3 wicket keepers, change this combination. Right? Like this, you keep moving and you'll get all these combinations here. And here, you have to form a committee. There are 4 officers and 10 clerks. You have to form a committee of 2 officers and 3 clerks. So requirement is 2 officers and 3 clerks. Now first condition is any officer and any clerk can be included. Any officer, any clerk. So simple, 2 officers you need from 4. 3 clerks you need from 10. So 4C2, 10C3. That's it. Second one particular clerk must be on the committee. So 1 is already chosen. So you have 10 clerks. 1 is chosen. That means you have 9 clerks left. You have to choose 3 clerks. In 3 clerks, 1 clerk is selected. So you have to choose 2 clerks. And the remaining 2 officers. And the third one particular officer cannot be on the committee. So you have 4 officers. 1 cannot be in the committee. So remaining officers is 3. Right? And you have to select 2 officers. So 2 officers. And 3 clerks from 10. That's it. The last one. An examination paper consists of 12 questions divided into part A and part B. Part A contains 7 questions. Part B contains 5 questions. A candidate is required to answer 8 questions minimum. At least 3 from each part. In how many ways can the candidate select the questions? Now, a candidate is required to answer 8 questions. Right? So total requirement is 8 questions. Part A has 7 questions. Part B has 5 questions. Minimum 3 in each. That means greater than 3 in each. So you start with the minimum value 3. If you select 3 questions from part A, you should be selecting 5 from part B, so that total becomes 8. If you select 4, then you have to take 4 here. If you take 5, then 3 here. So come up with all these combinations and add up all of them. For probability and ratio and proportions, like I said in the earlier video also, questions can come from anywhere, right? There is no limit to the kind of problems that can come from probability and ratio and proportions. Same is the case with permutations and combinations also, right? So thereby, try to understand the concepts well, right? Try to understand the concepts well and go through this revision video. Next one is application of derivatives. Now, this is similar to the 2 marker problems. You will see an overlap between 2 marker and 3 marker. The problem seems to be similar. So if you can understand the concept of application of derivatives, I think 2 marker and 3 marker both will be easy. These are the list of questions here from application of derivatives. Let's go through the solutions step by step. The volume of a spherical ball is increasing at the rate of 4 pi cc. Find the rate of increase of radius when the volume is 288 pi cc. See, the moment I know its rate of increase, it is nothing but I have to find the derivative. I have to differentiate, right? Now, volume of a spherical ball is increasing at the rate. That means you take volume as V. It is increasing at the rate of 4 pi cc. That means dV by dt. Rate means it's differentiating. It's differentiation. Rate means differentiation. Increasing also means differentiation. So dV by dt is, they've given us 4 pi cc. You have to find the rate of increase of radius. You assume that this is radius. Let R be radius. So you have to find dr by dt. You have to find rate of increase. Rate of increase is, you have to find derivative. So dr by dt. With respect to time, why do you say it's time? Because there is second. They've given here in the question seconds. Seconds. So this is a clue that it is with respect to time. So dr by dt you have to find, right? You should understand the formulas to solve application of derivatives, right? Volume of spherical ball is given. What is volume of sphere? 4 by 3 pi r cube. You differentiate this, right? And remember one thing, when you're differentiating here, you have to put dr by dt, right? You're differentiating r with respect to t. So it's dr by dt. dr by dt is what we have to find out. dv by dt is given, 4 pi cc. Substitute and you will get dr by dt. Simple problem, right? You will get dr by dt, which is 1 by r square. Now, I don't know what r is, right? So, one more thing given in the question, volume is given. Volume is given, 288 pi. So what I will do, I'll substitute 288 pi here in the volume. So if I substitute this in the volume, I'll get R. I can get R from this, like this. I'll substitute volume and I'll get R. So R is 6 centimeter. Now what I'll do, I'll take 6 and substitute here. I'll get dr by dt. That is what I need to find out. It is radius per second. You have to put radius. You have to put centimeter cc per second. Right? It's given in cc. So unit is cc per second because it's with respect to time. So it is second. Second one is also similar. Right? Edge of a cube is given. Rate means it's differentiation. So you assume that edge of cube is x. So differentiation would be dx by dt with respect to time because minute is given here. Right? So 6 centimeter. Dx by dt is 6 centimeter per minute. How fast is the volume? How fast? That means time. Volume, we'll consider volume as V. Surface area, A. You have to find how fast volume and surface area is increasing when the edge is 10 centimeter. Edge is x, right? So x should be 10 centimeter. When x is equal to 10 centimeter, you have to find dv by dt. You have to find dv by dt and dA by dt. Why? Because they're asking you to find out the volume and surface area, at what rate this volume and surface area is increasing. So you have to find dv by dt and dA by dt. So you need to know the formula of the cube. What is volume of cube? It's x cube, right? So you differentiate. Find the derivative of x cube, which is 3x square. And don't forget to put dx by dt. You are differentiating x with respect to t. So dx by dt. Dx by dt is given as 6 here. So substitute. I substitute 6 here. X is 10 centimeter. They've given edge is 10 centimeter. Substitute x here. You will get dv by dt. Similarly, what is dA by dt? Area of cube is 6x square. Formula. Differentiate. You are differentiating x with respect to t. So dx by dt. Dx by dt is given here 6. You are substituting 6. Edge is x 10. So you get dA by dt here. Right? Surface area is always centimeter square. It's square. And volume is always cube. Remember, volume is always cube and surface area is always square. And don't forget to put the units, right? Per minute. Whatever they've given the question. If they've given second, put second. If they've given minutes, put minutes. If they've given centimeter, put centimeter. Similar problem. Circular patch of oil spreads on water. The area growing at the rate of 16 centimeter. Area is growing at the rate. That means you consider area as A. So dA by dt is this much. How fast are radius? That means dr by dt. Assume r is radius. Circumference, dc. Assume circumference is c. dc by dt. You have to find this. They've given diameter is 12 centimeter. If diameter is 12 centimeter, what is radius? Radius is half of it. Right? Radius is half of diameter. That is half of 12, which is 6 centimeter. What is area of circle formula? Pi r square. Right? Now, you find the derivative. Right? We don't know what is dr by dt, but we'll have to find this out. Radius we know, half of diameter, 6 centimeter. So put 6 centimeter. dA by dt is given 16. So you'll find dr by dt. Right? Next you have to find circumference. That is dc by dt. Formula for circumference is 2 pi r. So 2 pi, you differentiate, you'll get dr by dt. You found dr by dt here. Substitute, you'll get circumference. Fourth one, a ladder 15 feet long leans against a smooth vertical wall. So there is a ladder. It is leaning against the wall. Right? And it is 15 feet in length. If the top slides downwards, that means the ladder is slowly coming down. If it's coming down, that means this will go far, right? It will go away from the wall. It will keep on sliding. As this ladder keeps sliding down, this distance will keep increasing. It has to go apart, right? Now you need to find, as the ladder is moving downwards, how fast is it going apart from the lower end, right? This is the lower end of the ladder. How fast is it moving away from the wall? This is the wall. Now you assume that this height of the wall is y and this distance from the lower end of the ladder to the wall as x and y. Ladder they've given as 15 feet. If you notice, this looks like a right angle triangle. So whenever there's a right angle triangle, you need to use Pythagoras theorem. What is Pythagoras theorem? Hypotenuse square is equal to adjacent side square plus opposite square, right? That is, you take both the sides. Square of this side is equal to hypotenuse square. This is how it is. AC square is equal to AB square plus BC square. AC square is equal to AB square plus BC square. Now we assumed AB square as y and BC square as x. But they have told you have to find when the lower end is 12 feet away from the wall. Lower end of the ladder is 12 feet away from the wall. That means x is 12. So put x as 12 here. That is BC. This BC is 12. So substitute BC here, right? And AC, what is length of AC? Nothing but ladder length. It's 15 feet. So this way you'll get y value. You'll get y value, which is 9 feet here. Now, what am I supposed to find? I'm supposed to be finding how fast the lower end is moving when the lower end is 12 feet away from the wall. That means I have to find this rate of movement. What is this? X. So I have to find dx. With respect to what? It's how fast with respect to time. So I have to find dx by dt. And when x is 12 feet. So now I'll differentiate this Pythagoras theorem. I'll take the same x square plus y square is equal to 15 square. Nothing but, this entire formula. AC square is equal to, AC square is 15 square. AB square is y square. BC square is x square. So I'll take this equation. I'll differentiate, right? And then I have to find dx by dt from this expression. dy by dt, do I know dy by dt? dy by dt is 2 feet per second. Top sliding downward. That means what is this? Y. It's sliding downwards, right? So it's y. So it's dy by dt. dy by dt is 2 feet per second. Right? I substitute dy by dt as 2. Y I already obtained here, 9. And I can find dx. And x is 12 feet. So I'll get dx by dt. Next problem. Displacement is given. The equation for displacement is given. Find the time when acceleration is 14 feet. Simple. What is acceleration? If I differentiate displacement twice, I'll get acceleration. So once I find the derivative, then I find the derivative again, second time. So I'll get 12t minus 10. They've told find the time. I have to find t when acceleration is 14 feet. That means dA by dt is given as 14. So I put 14 here and I'll find t, which is 2 seconds. Second question, find the velocity. Velocity is when I differentiate s once. When I differentiate s once, I get velocity, right? So this is actually velocity. Velocity is ds by dt. Now I have to find the velocity when t is equal to 2 seconds. Substitute t, I'll get velocity. Displacement, directly take the displacement equation, this one, and put t is equal to 2 seconds. I'll get displacement value. Don't forget to put the units. Units, whatever is given in the question, same units you have to put. Feet, second. Find the maximum and minimum value of the function. This is the function. Now, if you have to find the maximum and minimum, you will have to find double derivative. Based on the value of the double derivative, right, you will know if it is maximum or minimum. If double derivative is greater than 0, then it is minimum. If it is less than 0, then it is maximum, right? Again, refer my videos on application of derivatives, right? It will be difficult to explain entire concept in one video. You'll have to go through those different videos based on concepts. Now here, I'll touch upon at a high level. Now you'll have to take the first order derivative, differentiate this function once, you'll get this one, equate it to 0. Once I equate it to 0, I can find the value of x. See, always we have to find the value of x. Once we find the value of x, then we'll have to find the double derivative. Here you have to find the double derivative, which is 18. 18 is greater than 0. Since it's greater than 0, it's minimum. We call the function is minimum. At what point? When x is equal to minus 2 by 3. That's what we found out, right? X value we found, minus 2 by 3. Right? Now to find the exact value, you'll have to take this x value and put it in the function. So now you'll get the exact value. So exact value is, minimum value is minus 2. Now you have to show that x to the power x is minimum at x is equal to 1 by e. How do you do that? To show that x bar x is minimum, condition is double derivative should be greater than 0. This is the condition. And then you have to find the value of x to get the actual minimum value. So we'll first find single order derivative. You will get this one, this expression. Now you equate it to 0. So once I equate it to 0, I'll get the value of x. Now to find the minimum, now I'll have to find the double order derivative, second order derivative. This is a second order derivative, right? Now in this second order derivative, I'll have to substitute the value of x. So wherever there is x, I substitute it. Here, if you notice, after substituting, I should see if it is greater than 0, less than 0. Here, this is going to be greater than 0. See, you don't have to really calculate, but E is always greater than 0. The value of E is always greater than 0. Therefore, the entire expression will be greater than 0. Therefore, you can say it is minimum at this particular point. X is equal to 1 by E. You have to show or prove that this is minimum at this particular point. To prove that, you will have to first take single order derivative, find the value of x, then find the second order derivative, substitute the value of x in the second order derivative, and then see if it is greater than 0 or less than 0. There are detailed steps given in the playlist. You can refer that for solving such kind of problems. Next one, find the maximum and minimum value of this particular expression. Same step. First find the single order derivative, equate it to 0, get the value of x, right? Now take this value of x. Now you find the double order derivative, second order derivative, take this value of x, substitute, see if it's less than 0 or greater than 0. Here it is less than 0, that means it's maximum. Now you need to find the value. So again, put this x is equal to 1 in the original function. When you put this value of x in original function, you'll get the maximum value. So you got two x values here, x is equal to 1, x is equal to 5. So you have to substitute x is equal to 1 and see if it is greater than or less than 0. Then take the next value of x, again check if it is greater than 0 or less than 0. Here it is greater than 0, so function is minimum. To get the minimum value, take this x is equal to 5 and put it in the original function. You will get the minimum value. Next problem is to find the output at which MR is equal to MC. This is, cost and revenue based problems. I think this is the simplest of all in the entire application of derivatives, right? This is simplest. Try to, focus on these problems. This is relatively simple. So total revenue function is given, cost function is given. Find the output. So MR is equal to MC. What is MR? Marginal revenue. Marginal revenue means you have to differentiate revenue. Marginal cost means differentiate cost. Differentiate that. You need to find the output when MR is equal to MC. Equate. You have got MR here. You have MC here. Equate. You'll get value of X. So X is 45. This is the output. Output is 45. Output means it's the number of units. Number of units. The next problem. Again, cost function is given. You have to find the number of articles. Q is number of articles. Q given here is number of articles. You have to find the number of articles produced at minimum cost, and you have to find the minimum cost. So minimum cost means what? You have to differentiate cost. So you'll get this expression. Now you equate this expression to 0. When you equate, you'll get value of Q. You'll get value of Q. Once I get the value of Q, you have to check if it is minimum or not, right? That means you have to double differentiate. Now you double differentiate, right? You'll get this. Now you put the value of Q in this particular expression. So you'll check if it is positive or negative. It is positive here. Since it is positive, it means it's minimum, right? Remember the condition, if double derivative is greater than 0, that means it is minimum. So minimum cost. Now how do I find the actual cost? Whatever value of Q you have obtained, put it in the original function. Original function. Remember, not in the derivative, in the original function. This is the original function, right? In this function, you put the value of Q. And you'll get the minimum cost, rupees 41. Last problem, divide the number. I think even in the 2-marker video this was discussed, right? Divide the number 40 into 2 parts such that the product is maximum. Again, this is the simplest in application of derivatives. Focus on this problem also. Relatively, this and the earlier problems are simple. Let the 2 parts be x and y. So when you add, the total is 40 and the product is maximum. That means when I multiply x and y, x into y is maximum. Let's assume that P is equal to, product is equal to x into y, and it is maximum. Maximum means what? When double derivative is less than 0. This is the condition. So once you solve the problem, ensure that you verify that it is maximum. Now first we'll find the single order derivative. We'll differentiate this. What you have to do is first substitute y. Substitute y. What is y? 40 minus x, right? Y is 40 minus x. So in this product, substitute, instead of y, I put 40 minus x. So it will be 40. I'll multiply this. So I'll get 40x minus x square. Now I'll differentiate this, right? Now I equate it to 0. This is a standard step. Once I find the derivative, equate it to 0. The reason you equate it to 0 is to get the value of x. Once I get the value of x, I will get, this is x is the first number. I will get the value of second number, right? So it will be 40 minus x. First number is 20. Obviously, second number is 20. So two numbers are 20 and 20. Now I have to verify if the product is maximum. So I'll take the double derivative of this p. Double derivative will be minus 2. It's less than 0. Negative means product is maximum. So it's proven that the product is maximum. So next topic is integral calculus. Now there are three different methods, right? Integration by substitution, integration by partial fractions, integration by parts. Now, how do you know when you have to apply what? I will create a separate video on how to figure out when you should apply these different methods. But for now, I'll touch upon at a high level. When you see that the derivative, first thing when a function is given, check if the derivative and the function are together. Either it can be in the numerator or it can be the denominator, right? Just check the function and see if derivative is there. If it is there, then use substitution. Partial fractions when you have multiple terms in denominator, right? And then parts is when you have product of two functions, that is multiplication of two functions are there, and then there is no derivative. That's when you use integration by parts. Now here are the questions. These are the list of questions. See, these are just example problems. Now problems could be anything, right? The idea is by looking at these problems, you should be able to understand what method needs to be applied and how to solve the problem. You can try this for practice, right? So this first one is you can use a substitution method. This is partial fraction. This is you have to use a different technique, plus 3 and minus 3. You have to add plus 3 minus 3. And here parts, here use substitution method, here also, right? Here you have to use partial fraction method. So let's go through these problems, right? So here you see, first look at the function. This is the function. Is the derivative present? What is derivative of 3x square? 6x. Derivative of 5x is 5. 6x plus 5. So derivative is present here. Function is here. So when both are there, what do? Substitution method. Now you substitute the function as t and you differentiate this function, right? I differentiate this particular function. So I'll get this. Then I have to find only dt. That is, I have to take dx this side. So I'll get 6x plus 5 into dx. So here you have 6x plus 5 dx. Substitute dt here. So here I substitute dt. And then I have this. This one is t and the power. Don't take the power when you substitute t here. So here it will be t to the power 5 by 3 power. Then use integral formula, right? Increment the power and put the incremented power in the denominator. That's it. Simple. Here, which method to use? You have two terms in the denominator as product. So partial fraction, simple. Solve the partial fraction. So you'll get this particular partial fractions, right? Then simply find the integral separately. So 1 by x minus 1, log. What is integral of 1 by x? Log. But instead of x, you have x minus 1. So put x minus 1. Similarly here, x plus 2. And always put the coefficient of x in the denominator. Here, there is no coefficient. It's only 1. So you don't have to put anything in the denominator. Assume that you had 3x here. Just assume. Then you'll have to put 3 in the denominator. The third problem. This is slightly tricky. Check. Is the function and derivative together? Function, say this is a function. What is the derivative of this? It's 2. Right? But you have 2x here. So substitution method will not work. You have to use, and do you see multiple terms as a product like partial fraction? Do you see something like this? No, right? If something was like this, then you could have used partial fraction, but that is not true. So this, you can't use partial fraction. Now this is little tricky, but in this cases, ensure that you make the numerator same as denominator, because partially it is same. Here you have 2x, here you have 2x. Partially it is same. You have to make it fully same. To make it fully same, what you have to do? You have to add 3 and minus 3. Right? Now you have 2x plus 3 by 2x plus 3. It will get cancelled. You will get 1. Integral of 1 is x. And this one. Assume that this is this 2x plus 3 as 1 by x. What is integral of 1 by x? Log. But instead of x, I have 2x plus 3. So I put log of 2x plus 3. And see here, notice here. What is coefficient of x? 2. So put 2 in the denominator. Now this one. You have product of two terms. Product of two functions. This is one function. This is one function. This is one function. And one is not the derivative of the other. Is x square the derivative of log? Is log the derivative of x square? No. So it is parts. You'll have to use integration by parts. Right? Now refer the playlist for solving integration by parts. Very simple. But go through this. Here you see. First check. Is the derivative there? What is the derivative of sin x, cos x? It's there. So use substitution. So assume that t is 1 plus sin x. Differentiate. You'll get cos x. Just find dt. Transfer dx here. So you'll get cos x dx. Right? Substitute and you'll get the answer. Fourth one. So here again observe. Is the function and derivative together? Derivative of x is 1. Derivative of e to the power x is e to the power x. So you get this. So this is the derivative. So both are together. Simple. Use substitution method. Right? Next one. Here. Whenever trigonometry comes and there is something like this, it becomes tricky. So what do? You'll have to think a little bit here. Now, whenever you have this addition and subtraction of trigonometric functions, you will have to use for sure some trigonometric formula. Some trigonometric formula has to be used. Now, there is a formula for cos 2a. Cos 2a is 2 cos square a minus 1. Also, cos 2a is 1 minus 2 sin square a. So, if cos 2a is 2 cos square a minus 1, then cos a is submultiple angle formula. A will become a by 2. 2a becomes a will become a by 2. Use this formula or use this formula. One of this formula you have to use. Now, how do you know which formula to use? Use a formula in a way that this 1 will get knocked off. This 1 has to get cancelled. That is the way you have to use a formula. If I use this formula, cos square formula, this plus 1 and this minus 1 will get cancelled. Thereby, I have to use this formula. Similarly, in the denominator also, I'll use the same formula. But what formula? This 1 has to get knocked off. If I use the sine formula, then this 1 will get cancelled. That's all. That is the clue. Now, you simplify this. Cos square and sin square will become cot square. Now, this is a very important trigonometric formula. Cot square x is cosec square x minus 1. Similarly, you have formula for tan square x, which is secant square x minus 1. So, use this formula and then you find the integral separately. Integral of cosec square x is cot and integral of 1 is x. Last problem, again, is the function and derivative together? Function is x, derivative of x is 1. No, it's not there. You have x here. So, you have to use partial fraction because it's product of two terms. Multiplication of two terms in the denominator. So, use partial fraction. Next topic, differential calculus. Here are the problems. Again, just practice these problems. You can focus on parametric differentiation. Right? And then you have problems on logarithmic differentiation. This is important. And infinite series, very easy. Implicit function, this is also easy. Now, let's go through the problems. Parametric function means you have three terms. You have x, you have theta, you have y, you have theta. So, you have three different parameters, right? So, that's why it's called parametric. You're trying to find dy by dx, but you have theta here as the term. So, what I will do, I'll first differentiate x expression with x. So, dx by d theta I'll get. Then I'll differentiate y with respect to theta, dy by theta I'll get. If I have to find dy by dx, I need to take dy by d theta divided by dx by d theta. Then what's actually going to happen is d theta will get cancelled. So, I'll get dy by dx. So, I'll take derivative of dy by d theta as sin theta, cos theta, I'll divide that, I'll get dy by dx. Parametric function is very easy, right? Focus on this. Find dx by dt, dy by dt, then take both these expressions and divide, right? And you'll get dy by dx. Here also similar thing. Dx by dt you find out, dy by dt, then divide both and find the value. Now, when you have something like this, differentiate tan root x with respect to x. What you have to assume is, this is one expression, this is one expression. So, assume that y is equal to tan root x and t is equal to root x. You can also assume that this is u and this is v, whatever. You name it the way you want. So, you have two functions here, u and v. You have to differentiate this one with respect to this one. Now, when I say with respect to root x, that means this should be in the denominator. This should be the denominator function. So, it should be tan root x. You're differentiating like this, tan root x with respect to root x. Right? Now, what is tan root x? I've considered as y. So, dy. What is root x? I've considered as t. So, it is dy by dt. Now, so I'll differentiate this separately. When I differentiate this, I differentiate with respect to x. Whatever is here, I'll differentiate with respect to that particular variable. So, I have x here, so differentiate with respect to x. Here also I have x, so I'll differentiate with respect to x. Divide both of them, I'll get this. Next one, differentiate tan square x with respect to cos square x. Again, assume that u is tan square x, v is cos square x. You have to find du by dv. That is, this should be the numerator function. This should be denominator function because it's with respect to cos square x. With respect to cos square x means this is denominator. And what is denominator? V. So, dv. Differentiate this u function, v function, divide it and you will get the answer. Sixth one, same thing. How do you know if it's parametric? You will see two functions and third parameter. You will see three parameters, x, y and something else like theta or t or something. So, when you notice there are three parameters, use parametric function. This is another one, right? Same approach. Here, this is logarithmic problem, right? So, now, how will I solve? Whenever I have powers, what is the clue? How do I know when I have to apply log? Simple. If you have a variable as power, in the power, if you have variable like x, y, z, then you have to use logarithm. Or if you have trigonometric function, if x to the power sin x, x to the power tan x, then I have to use log. So once I apply log, there is log property, right? If I have something like this, if I apply log, it will become y log x. Log m to the power n is n log m, using this log property. So I'll get this log e. Remember this, log e, value of log e is 1. So I'll get y minus x. Take y to the other side. When I take y to the other side, I'm left with x here, right? Then I'll find only value of y. Y is equal to this much. Now I'll differentiate, because I have to find dy by dx, right, ultimately. So I'll differentiate, I'll get dy by dx and solve this. You have to prove that this right hand side expression is true. Next one. Okay, here again you have logarithmic. Sin x to the power tan x. Simple. What you will do? Apply log. So you'll get tan x into log of sin x. Tan x will become the power, right? So it will come here. Tan x into log of sin x. Log y. Differentiate. Infinite series. This is again very simple. Infinite series is the simplest one in differential calculus. Simple, right? You assume that y is equal to, you put the square root as is, put sin x, first term you put, then remaining else will be y. This remaining everything should be y. So it will be sin x plus y, right? Now I'll find derivative. Once I find the derivative, I get dy by dx is here. So I'll get this right hand side. This problem is a little lengthy, but it is simple. This is another infinite series problem, right? Take the first term, e to the power x, then remaining everything else is y. That's all. Take the first term out and then add it up with y, like this. Here you have to add it to the power. Remember, don't make it like this. No, this is wrong. So it should be, first term is e to the power x, right? And how actually it is like this, x to the power e to the power x, again x to the power e to the power x, again x. This is how the series is. It goes like this. So how I should remember this? I'll take the first term out, which is e to the power x, right? Now what is this entire thing? It's to the power only, right? It's to the power. So I should make it, add it with what? What is this entire thing? Y only, right? So it will be like this, to the power. Right? Now I apply log. Why? Because it's to the power. There is power. There are two variables in the power. So I apply log. And log e is 1. That's all. Right? You differentiate. So I'll get log y minus y is equal to x. So what I'll do, I'll differentiate. Then rearrange the terms. And you'll get this expression. So last problem. Find dy by dx. This is an implicit function. Implicit function is nothing but you have x and y mixed up, right? See here, x and y is mixed up. So it's called as an implicit function. But it doesn't matter when we solve whether it's implicit or not. What we will do here is log xy. So this is of the form like this. Log xy can be written as log x plus log y based on logarithmic law. So I'll split this like this. Now I'll differentiate on both sides. So get all the dy dx terms on one side and the x terms on the other side, and then you will find dy by dx. All the x terms on one side and dy by dx on the other side. So with this, we've come to the end of this particular video. If you found this video useful, do press a like and share it. Thank you.